Hey everybody, welcome back. Mike here. In today's video, we are going to talk about how to use decoy IP addresses with your nmap scans to evade detection. So if you're a defender, this is a great lesson to see what is possible with nmap. If you are on the attacking side, whether on a red team, an independent penetration tester, whatever the case is, then this is also good to know because this will help you avoid having your actions uncovered essentially in the middle of your engagement. So let's get right into it and let's talk about decoys with your nmap scan. So just to lay the foundation here, I like referring back to official documentation because it's spot on and it's more accurate than anything I would write. So let's go down here. I want to show you this option right here. The option we're working with is -D, and after that we then specify a decoy IP or multiple IPs ideally. And what this will essentially do is generate scans from those IPs as well as our own. So essentially we're creating a lot of noise to hide our scan in the middle of the noise to make it harder to spot which one is legitimate, which one isn't. Now the one thing I do want to mention here before we get into the lab, there is a mention here. Decoys do not work with version detection or TCP connect scans. So we will be using a SYN scan to accomplish this. That's about it though. The only other thing I would probably add is you can actually, one of the challenges with this specific method is, let's just think about this. We have an environment where we have, I don't know, 100 hosts, right? 100 servers, and we're doing a scan, and we're using decoys. Well, what happens, if you remember our lesson where we talked about SYN scans and how they worked, right? We called them half-open scans. So we're sending SYN packets to all of these systems on a port, and potentially opening the port, right, at least halfway, and that system replies back with the SYN-ACK, right? Now, one of the challenges, if we have, let's say we do 10 decoys, we have 10 different IPs sending the same SYN packets to all of those systems, so you can unintentionally SYN flood those systems and cause issues. So just be aware of that. Now, in our case though, let's go ahead and let's flip into the lab. I want to show you what we're working with here. So I have this Kali system right here, nothing special, pretty much a fresh install. And in addition to that, I am actually capturing, let me open up Wireshark here. I'm capturing all of the traffic coming out of Wireshark, or coming out of Kali, out of that VM. Which, by the way, just to show you a quick trick here that's really cool, if I go into the Wireshark settings, the interface I selected to do this capturing is actually an SSH remote capture, or SSH dump. If I click the little gear next to it, it'll actually give me the settings. So this is the IP address of my Kali Linux VM. I'm using SSH on port 22. For authentication, I put my username and password, which are pretty much throwaway because I blow this VM away constantly. And then I also, if I go to capture, I specify the interface I want to capture on, and in this case, what kind of command I want to use. I'm using a tcpdump scan. And then the last piece, I'm using sudo on the remote machine on my Kali box. So basically what this means is that with this setting, my capturing station running Wireshark will actually SSH into Kali, run a TCP dump, and pull all of that data into Wireshark. Pretty cool, actually. And by the way, it's a great way to learn about this stuff because once you see actual packets, it really puts things into perspective, makes it a little simpler. All right, so in this case though, I'm gonna close out of that. I'm going to start this scan and we'll just let that run. So we will see packets start to pop up here. Now we're gonna ignore that for now. Let's go into the lab and let's start doing some scanning. All right, so our objective first is to identify how we can use this decoy scan. Now, first thing I'm gonna do, remember we have to do a TCP SYN or stealth scan. We cannot do TCP connect. So in this case, I'm going to do sudo nmap. And in this case, I'll do a -V for verbose. I'll do a -N so we disable DNS resolution. And in this case, I'll just specify my IP that I want to scan. I'm actually going to do my home range. That should work. Now from there, I'm just going to do this. We're not doing a decoy scan yet. I want to show you the results here. So if I run this scan and I flip back over to Wireshark, let's go see what we got. Look at this. Let me scan through here until we find, these are all ARP. Yeah, so if you see, look through this real quick. Let me stop the scan here. if you see this, look at this. We can see 192.168.0.60 is scanning all of these IPs, right? I selected the entire range, so 256 hosts essentially. But we see all of these SYNs being sent out. And by the way, we could actually see in more detail if we actually open it up and scan through here. We can actually see all of the details for that. Specifically, if we go down, yeah, this is tiny. There we go. We see SYN is set. And if I go up, you can see it's under flags. So it's essentially a TCP packet that has a flag for SYN. That's what makes it a SYN packet. So in this case, these are just SYNs in which, yeah, of course, as I said that I forgot, it was right here also. So we can see there's a SYN. So we're sending out all those SYNs to all these workstations from our IP, 192.168.0.60, nothing new there. We're getting back all of these resets. These are the ones in red. So you see reset, comma, ACK. These are all of the target systems saying, oh no, that port's closed. I'm sending you a reset just to let you know. So those ports we know are closed for sure on those systems. If we were to go through here, I don't know how many ports we'll see open. There's a lot of traffic here. But if we were to scan through here, let's see if we see anything quickly. Oops, let's go here. Yeah, SYN. Just see if we see anything. We can't actually filter on this, but I am lazy, if I'm being honest. Let's see if we see anything else. You know what we can actually do? Let's do this. We'll do IP. We're going to add a filter in Wireshark. We'll do IP.dst host, and we'll do equal, and we can specify our IP address. So we're looking at replies to us. All right, so that's all replies to us. Now if we go through here, what we can actually do, we can click on all those reset packets. And let's go back under here in this pane. Let me open this up a little bit so you can see what we're doing. So I'm looking at the packet details. So if I arrow down, you can see the details change here. But these are all reset ACK packets. So what I'm going to do is I'm going to go to flags right here, open this up. Where it says reset set, I'm going to right click on that and say apply as filter not selected, I think should do the trick. There we go. So what I did was I just eliminated any reset packets from our view here. And I'm going to say, I think we can do and IP destination host is us because it cleared out that one I had. So we'll do 192.168.0.60. All right. So basically what we did is we prepared a filter to get rid of those reset packets and look at only packets to us. So if I run that, now what we should be left with, look at that. That actually worked really well. I promise you guys, I haven't done this in a while, but it actually worked. Look at this. We see all of these replies from all of these hosts on my network to me, to Kali 0.60. Look at this. They're all SYN-ACKs. And I can actually tell, by the way, this first field right here, these are all port numbers. So I have my results from my port scan right here by looking at raw packets. I can see port 80 is open on .48, .50, .1, 20,005. I have no idea what that is. Yeah, so anyway, you kind of see where I'm going here. The point is, I got derailed. We're doing some Wireshark kind of wizardry here. But the point is we can see that we scanned all of those hosts directly from my Kali VM. Now, what I want to do at this point, I want to clear that flag, and I'm going to actually restart this scan. So we're blank. And let's go back to Kali. Now, from there, what I want to do this time is we want to do our decoy scan. So our problem is, as you saw in that packet capture, there was a lot of noise from only us. So we're basically in the room like, hey, everybody, I'm doing a port scan. Just so you know, my IP is 192.168.0.60. If you want to come catch me, I'm right here. That's basically what we did. So let's fix that. Let's use the -D, which, by the way, if you do nmap, I believe it's -help. If you go here, let's scroll up a little. You can actually see the syntax right here. So capital D, and then decoy. Now you'll also see this option in here says me. I want to explain that in a second here. So let's build out our command. I want to make sure I mention that me part of it. Now what we do is we do -D. I'm going to create some space there so you can see what I'm doing. Then we specify directly up against the D, we're going to start typing in IP addresses that we want to basically spoof packets on behalf of those systems, right? So if I put in, I don't know, let's do 192.168, I'll do 0.254, right? Actually, you know what? Let's pick something like really bizarre so it easily stands out. So we'll do like 2.1.0. I don't know, 111. How about that? Yeah. Okay, so we'll just pick one there. I'm going to do a comma. We'll do another IP. We'll do 2222.3333, something like that. And then, you know what? If I'm going to do that, I might as well make that a 1. There we go. So what this will do is it will scan all of the systems on my local subnet, but it will generate duplicates of those scans, not only from me, but from these IPs, right? And now this isn't going to do anything because the systems that get scanned will reply to those IPs with a reset packet, say, hey, you got the wrong guy, right? Essentially. Or potentially a SYNAC if the port is open, but it won't go anywhere because the systems on the decoys that we're using will not be expecting anything, right? So let's go ahead and actually, you know what? I was going to do this, but I have a feeling someone is going to watch this and just flame me over using a public IP. So let's go ahead. We'll just do 172.116, 1.1. We'll do 172.16, 1.2, 172.16, 1.3. Okay, I like that better. That feels better. Even though it wouldn't have mattered, there was going to be someone that was going to be really grumpy about that. All right, so this is good. Now we've got our decoy command. Remember, capital D and then all of the IPs, comma separated there. Now let's go ahead and run this. I'm going to hit enter, and let's flip over to Wireshark. And I'm actually going to restart it again, so we'll have less noise here. All right, so I'm going to stop it right there, actually, because we already got what we needed. Let me go flip over here and just kill this scan. All right, so what we saw here, just like before, we had our scans from our Kali Linux VM, 192.168.0.60. But now we see that in addition, basically what's happening is nmap is saying, in this case, let's see what port we're scanning. Is this right? 33,280? I guess that's right. So in this case, we're saying, is this port open? And we send it from us, from Kali Linux. Then we say, also, let's send another packet from 1.1, from 1.2, 1.3. And then we go back, we change to a different port, right? And we start repeating the process and sending it again to this port. And now we kind of go through that list. So for every one packet from us, we're sending, in this case, 3 others from other workstations. Now, the one tip I will give you here, typically you want these decoys right here, we want these to be ideally live systems. So that's definitely a recommendation. So ideally, you'll kind of do some recon and say, okay, well, we have a couple of live systems. And also, by the way, it hides it a little better if it's something local, right? It might actually look like, hey, that system was just acting kind of funny. So that's ideal. You do want that to be a live system if possible. Now, in addition to this, let's go ahead and get rid of, let me stop highlighting. All right, so what we can also do here is we can do -D. And if we don't have any IPs we want to list specifically, we can go ahead and do D and then RND for random. And if we do that and just that, it'll generate a random IP just one, right? So we'll have a decoy that is a completely random IP. This IP will not be a 192.168 address. It will be a public IP, or it could be a public IP, I suppose. What you can also do, though, is you can do a colon and specify a number. So if you say 10, what this will do is generate 10 random IPs as decoys, and it will generate the scans from those. So if I go ahead and run this, and we flip over to Wireshark, let's go ahead and see what we got. Okay, we got some scan results. Let's cancel that. Look at this. We now see that we're scanning every IP many times, right? We have all of these from many different IPs, and mine now, that 0.60 is hidden in the mix quite a bit. So that's a really cool feature. It's very easy to generate those from many different IPs. The one last thing I'll mention here before closing out for today's video. Now, you can have this comma-separated list. So if you do, let's say we do, I don't know, I'm just going to demonstrate just to, I'm not going to actually run this scan, but just to make it simple, let's do that one that someone would be freaking out about right now. So we've got 4 IPs here. All right. Now, we can do a bunch of decoys, and a lot of IDS systems will actually not detect anything past around that 6th IP address. So what you can actually do is there's kind of a, I guess it's sort of a variable almost. You can do me, and that will place your IP address farther in that list. So you'll get all the noise up front and then your IP. So just to illustrate that point, by the way, let's go ahead and just do, let's do random, we'll do 5, comma, I think that should work. So we're gonna generate 5 random IPs, and then ours will be the 6th, essentially. So let's run that scan. And let's get some results here. I'm gonna restart this. All right, let's go back to our, okay, there we go. So it took a minute. I'm gonna cancel now. It took a little bit, if you saw there. Let me go back up to the top. Yeah, so it said ARP ping scan. So it was taking a little bit. That's why we saw all this ARP traffic. If we scroll down, there we go. There's all of our scanning happening. Let's go way down here though. Okay. So now if you see, this is pretty cool. So let's find a port that we start scanning. Let's do, I'm looking right here, by the way, to find the port that I want to scan on. Oh, whoops. Yeah, I was looking at the wrong field. My bad. That was the source field. So let's do this port right here. So look at this. So these are all of our ports to TCP 179, which is actually the BGP routing protocol. Your useless tidbit of information that you didn't need to know today. So we're scanning that port. And actually, these were actually replies. So I guess what we could do, I believe we could do TCP, yeah, there we go. Thankfully I typed this before. We'll do TCP port equals 179. All right, so let's just look at that traffic. And I want to do and IP source host. We'll do, actually, no, we don't want to do that. Let's do IP destination host we'll do this 29 address. So what I'm really looking for here is just all of our scans to that one host, because I want to show you something here. So there we go. So now we see all of our scans, and actually these are still the responses. So I probably messed up somewhere here, but oh, you know what? We would, yeah, okay, that's what I was looking for. Anyway, words. So what we essentially did here is we looked at all scans on this port and specifically to this one IP, right? So what we see, we have all of this stuff here. Now, you notice when I ran this command, I did decoy, I did rnd:5, which means generate 5 random IP addresses, comma me. Me is a placeholder for my Kali Linux IP address. In this case, 192.168.0.60. So what this essentially means, if we go back, now I'm really hiding in the noise because the first IP is not mine. The first scan, right? It's some random IP. We go down here, the 2nd, 3rd, 4th, 5th. Those are not mine. Mine is the 6th. So if you really wanted to, you could do generate 5 random IPs, mine, generate 4 random IPs. And yours would be in the middle of all of this noise, which would just be absolutely a mess trying to isolate. That's all I really got for you guys today in this video. I hope you found it useful. This was a little more informal than what I normally do, but I really think there's a lot of value in looking at the actual traffic, especially for nmap, so that we can understand what's going on at the network level, that we know ultimately which flags to use, what are the effects, that sort of thing, instead of just reading documentation. So that said, if you found this video useful and you want to see more content like this, let me know. Drop a comment below and make sure that you subscribe and hit the bell. If you don't hit the bell, you won't get any notifications. I myself am guilty of that. I will subscribe to channels and never come back. So make sure you hit the bell. I'm not going anywhere. I've been doing this a couple of years. I got more content planned. I'm rebuilding the home studio, so it's gonna get really, really awesome really soon. Well, I guess hopefully it's awesome already. I don't really know. I'm falling apart at the end here. So that said, I hope you guys stay safe and healthy. Until next time, stay nerdy.